Hey everybody, today we're going to go over isotopes and ions. Let me go ahead and share my screen again. All right, so we're going to be on page 5 in your packet, about halfway down, where you see some information about isotopic notation. So when we're talking about a specific atom, there's a couple of different ways where we can indicate which particular atom we're talking about. So the first manner that we can do this is where we have the element name followed by the mass number, okay? So when we have carbon 14, carbon is our element, 14 is the mass number. So in order to find the protons, you would just look at your periodic table to see what the atomic number of carbon is. We know that the number of protons in carbon is going to be 6. We know that if it's a neutral atom, the protons are equal to the electrons, so the electrons would be 6 as well. Now, in our last video, we learned that the mass number is equal to the sum of protons plus neutrons. So in order to get neutrons, we would just subtract the protons from the mass number. So we would have 8 neutrons in this particular atom of carbon. The atomic number is the same as the protons. It's on the periodic table, so the atomic number is 6. And then the mass number, again, is following the name in the this isotopic notation written up here. So the mass number is 14. So let's try it out here. Potassium 39. So the symbol for potassium is K. So that means the protons for potassium 39 are going to be 19. It's a neutral atom, so our electrons are going to be 19 as well. To find our neutrons, we take the mass number minus the protons, because that will give us how many neutrons. So 20. The atomic number is the same as the protons. It's on the periodic table. So the atomic number is 19. And the mass number is following the name here, 39. The other way that we have the isotopic notation written is what we call the AZ notation. So you'll see it here. We have a superscript, a subscript, and then an X representing the element symbol. So our superscript is going to be the mass number. The subscript is going to be the atomic number. And then the X is representing the symbol of the element itself. So let's see how this looks. So if we have 3216S, well, the atomic number is here at the bottom, so we know that the protons are 16. The electrons in neutral atoms are equal to the protons, so the electrons have to be 16 as well. And then the neutrons are going to be the mass number on top minus the atomic number on the bottom, so our neutrons are going to be 16 as well. In this example, we've got 73Li. Li is for lithium. Again, the atomic number on the bottom is telling us our protons, so that's going to be 3. The electrons in a neutral atom are going to be the same as our protons, so that's 3 as well. And then our neutrons are going to be mass number on top minus the atomic number on the bottom, 4. 3717Cl, protons are equal to the atomic number at the bottom here, so 17. Electrons are equal to the protons in a neutral atom, so that's 17. And then the neutrons are the 37 minus 17 here, so that's 20. Now notice I have not gone to the periodic table to calculate my neutrons. I have not looked at this decimal point number that is underneath this symbol here. That's not coming into play yet, okay? So I'm just looking at the mass number that's given to me in these different isotopic notations, all right? Now isotopes, we had briefly mentioned isotopes when we were talking about Dalton's modern atomic theory, because Dalton said that, well, he thought that all atoms of the same element were identical, and that's not the case because of isotopes. Well, isotopes differ because they have a different number of neutrons, so they have a different mass number. When you look at these 3 examples here, these are all isotopes of hydrogen. We know they're all hydrogen because they all have 1 proton. Remember, the protons identify the atom, but they're all different because they have a different number of neutrons. One of these examples has 0 neutrons. One example has 2 neutrons. So we call them isotopes of each other. Ions, let me move my little picture here. Ions have the same number of protons because remember, we cannot change the number of protons. If we change our protons, we change the element that we're talking about. Neutral atoms have the same number of protons and electrons. Ions don't. Ions are charged particles. So that means that they have to have a different number of protons and electrons. If the protons can't change, that means that they have a different number of electrons. So that happens because of the way that these atoms interact and bond with each other. Something that we'll be talking a lot about this year. I have this shirt that's here at the bottom. I lost an electron shirt. Yeah, I'm positive. All right, so positive ions. Positive ions are formed because the neutral atom lost electrons. We can't add protons, we can only lose electrons. Electrons, remember, are negatively charged particles. So if you lose electrons, that means you have more protons than you have electrons. So aluminum 3+, we know that aluminum, let me get my annotate tool here. We know that aluminum has 13 protons. So in order to have a +3 charge here, that means it had to lose 3 electrons, and now it only has 10 electrons. So if it has 13 positives, but only 10 negatives, that's why it has a +3 charge. Iron here, iron has 26 protons, and it has a +2 charge, so that means it lost 2 electrons. So that means it only has 24 electrons now. Okay? Negative ions, in order to become negative, an atom has to gain electrons. They have to gain negative charge. So a P with a -3, phosphorus typically has, always has, 15 protons. So typically has 15 electrons as well, but if it has a -3 charge, that means it gained 3 electrons. So now it has 18 negative charges. Chlorine with a -1 charge, chlorine will have 17 protons because its atomic number is 17. If it gains 1 electron, that means it has 18 electrons. So 18 minus 17 gives you that -1 charge. Again, they would not be formed because of a change in protons, because changing protons would change the substance that we're talking about, the element that we're talking about. All right, so make sure you have your periodic table handy while we go over this. If you need a calculator, you can use a calculator. I don't have one, so hopefully I can calculate without any issues here. So here we're given information and we're trying to figure out the missing information here. So here we know that this is gold. So if we know it's gold, that will tell us some information. We can look up the atomic number of gold, and that's 79. So we know that the atomic number is 79, which is the same as the protons. Okay, this here tells us that the protons and electrons are not the same. A +3 means that it lost electrons, so our electrons would be 76. To find our neutrons, remember the mass number plus the protons, the mass number is going to equal the protons plus the neutrons. So we have to subtract the mass number, or the protons, from the mass number to get our number of neutrons. So that's going to be, oh gosh, 118? Did I do my math correctly? You can check me on that. And then our symbol over here, our element symbol, is going to be gold. All right, here we have lead. So the symbol for lead is going to be Pb. We don't know if it's going to have a charge yet. So let's look at the atomic number for lead, and lead is 82. That means that our protons are 82, because the atomic number and the number of protons are always going to be the same. Since the protons and electrons are the same, we are not going to have any kind of charge indicated on our symbol here. The mass number is going to equal the protons plus the neutrons, so that's going to be 204. Here we've got calcium, and we can see in the symbol here that our atomic number is 20, which means that our protons are 20. Because there's no charge on the element symbol, we know that our electrons are 20. This up here tells us that the mass number is 40, and then we can do mass number minus the protons to get our neutrons, and that's 20. Ooh, look at this row. We have lead again. Okay, here's where some students will make their mistakes. They're going to want to copy this row up here and put it down here as well. But remember, there's isotopes. We can't do that. So lead, we know that it has 82 as its atomic number. We know that it has 82 protons. Take a look at this. The mass number is different for both of these leads. Why is it different? Because those are isotopes of lead, two different isotopes of lead, which means that the number of neutrons are going to be different. This is going to be 125 because it's going to be the mass number minus the protons. There's no charge on our lead symbol here, so we know that the electrons are going to be the same as the protons, 82, and we know this is lead. Last example here, we have no element name or symbol, so let's look at this atomic number. It's going to tell us some information. When we look at the periodic table and look up the atomic number of 19, we see that this is potassium. So we know this is potassium, which is K. We can see that the protons are going to be 19 as well because of the atomic number is always equal to the mass, or the atomic number is always equal to the number of protons. Our mass number is going to be our protons plus our neutrons, so the mass number is going to be 39. We're not done yet, because if you look at this last column here, we have 18 electrons. We have 19 protons. That means we lost an electron. If you lose an electron, that means you have a positive charge, and we lost one electron, so +1 on that potassium, okay? So if you have any questions about calculating subatomic particles, please let me know. I'll talk to you later.